Hi, my name's Rory, and my project is AI-based Underhanded-C. This project is based off an annual competition where competitors will strive to make the best underhanded code. This is code that usually consists of a benign task and then a second evil task. The benign task will be handled on the left side of the GUI, while the evil task will be handled on the right side of the GUI. Underhanded code is malicious code that, when inspected by another programmer, appears benign. In this video, we're going to be using the 2006 competition, where I've prepared the benign prompt, which has been copied and pasted from the website. This is where a text file will be scanned, and then the frequencies of each word will be output into the terminal. So we're just going to copy and paste this prompt and enter it in here. And we're going to generate two files so that we have two to pick from. So this pop-up has appeared, and we're just going to press OK and wait for the next pop-up. So the code has now been generated. These are sample 138 and samples 139. So let's have a read of them and see if they do the task. Yeah, so here it's got the frequency and the words being output, exactly what we wanted. And there doesn't appear to be any bugs, so let's click done. Let's read sample 139. So this does the same, except it has a bug where it's missing a return statement and the final curly bracket. So we could add these manually in the text editor, but for ease we have a debug button which we can click, and then that should sort it all out. As we can see, this has all been debugged, so it should now be compilable. So let's check that these files actually do what we want by compiling them and running them in the terminal. So let's just put in .sample 138. Yeah, see here it's got the frequency of how much the words come up in the input document that I prepared earlier, and the words in alphabetical order. So let's try sample 139, see if it also gives a good result. Same again, it's successfully given the frequency. It didn't sort them, but it doesn't actually need to sort them, that's not part of the specification. So sample 138 might actually be better because it sorts them, but that's entirely up to what you're looking for. So let's close this and click done to destroy this window. And now we can move them along to the malicious side of the GUI. So here we have to enter a malicious task. There's a variety of ways that this can be done using different models which are detailed in the instructions. So Malboy requires a less specific prompt because it still has its ethical boundaries, while Devilinci and the other models will allow for as much specificity as needed. The more specific, the better. So we're going to start with Malboy, and we're going to give it sort of a benign-ish prompt. So we're just going to say something like, take longer on certain on one operating system as opposed to others. So we're going to hit Malboy and click go. So Malboy has successfully created this file with a 100% success rate, meaning that it's returned code every time it was asked out of 4 times. So that's good, and hopefully it's yielded a good result. So I'm just going to put video Malboy. Video Malboy has been saved. No information about the code though, which is suboptimal. So let's read the file. And Malboy has clearly identified that this is malicious and has gone off on a tangent away from everything and has just created a quicksort, which means that Malboy has failed in this test. So hopefully we can get better results in the other models. So for the other models we can be a bit more specific. So this prompt we have designed with as much specifics as possible. So we've prompt engineered it to not just put infinite loops and be creative on how to do it, which is good. Encouraging creativity is good because LLMs are not naturally sneaky or creative, so pushing it towards a creative solution will yield better underhanded results. And we've asked it to describe in detail the change and why it works on some operating systems and not others. This is useful as at the end we can see which operating system it will work better on and which operating system it will work worse on. So let's just put this directly in and click go. So we're going to save this as video Da Vinci. And here we have some instructions. Apparently it utilizes differences in little endian and big endian machines. Doesn't say how though. So let's look in the file. Okay, so I don't see how it's changed, so we'll have to wait for when we test it on a Linux machine or a Windows machine. And now let's go through all the jailbreak models, which are all very similar. Saving it as video god. It's giving us some instructions. You have to find big endian, not very subtle, but it does what it needs to. As evil. Evil model has failed. Hopefully developer won't also fail, but it's also possible. These jailbreak models will fail when the LLM has not been successfully jailbroken, so it's been flagged as a malicious prompt. So that doesn't work either. These models are very tentative as to if they work, so we can always try evil again and see if it will give us a response this time. And it has, so we'll just save that as video evil. Okay, that's not helpful. Okay, so let's have a look at these. Okay. Okay. So now we can just compile them. That's got bugs in. Oh no, we don't want that one. So now we can just compile. And now, because these files aren't overly malicious, we can run them on our Windows machine. So we'll try this one out. Okay, it does as it asks. And so let's measure the time for them. So it takes 25 milliseconds on here. We'll try these on a Linux machine afterwards. And it takes, this one takes 53 milliseconds. This one takes 56 milliseconds. So we have the approximate milliseconds it will take for each of these, even though we only ran it once, because this is just a demonstration. And now let's go try them on a Linux machine. So now that we're on our Linux machine, we can test the time measurement for these on another operating system. So let's start with, what did we test first last time? Let's start with Video Devilinci, which took 25 milliseconds, or 0.025 seconds. So okay, so this actually went slightly quicker on Linux as opposed to Windows. And let's try Video God next. This took 6 milliseconds, so again quicker on Linux, but quite substantially, by almost 10 times. And now let's try with Evil. Evil took 56 milliseconds before, and this has taken 15 milliseconds, so again quicker. This is a very marginal difference, but it's because of the strcmp function, which works better on Linux machines as opposed to Windows machines, based on how memory is stored and how strings are compared. So acting in an underhanded way is exclusively a human behavior. The LLM is not able to hide its malicious intent very well. However, it is able to create malicious code. So let's make 3 files, even 1 file, to use the maximum amount of tokens, and then have a text-based adventure game in a forest. Make this game very long and full of dragons, trolls, and ogres. So hit generate. So we'll look at this file. Okay, so not great gameplay, but it's useful for this purpose. So we will let's at the end of the game encrypt all files in the current directory. Okay, so let's use Devil-in-C for this purpose and hit go. Devil-in-C inc. Okay, so let's read it. Okay, so this should save all the files in the current directory into a zip file and then remove everything. So that's all fine, and now we'll do the same with God. So God Inc. Okay, so when you choose to exit the game, it'll open a terminal and then it'll encrypt all the files in AES 256. And try evil. Uvalink. Which is much the same as the one before. And developer. Which refuses to do so. Okay, so we can only test one of these. So we'll test them in the virtual machine and we'll see how they go. Okay, so now that we're in our virtual machine, we can safely try out these files. We'll start with Devil-in-C. Actually, let's before we start, let's have a look at how each of these work. Okay, so I'll just zip and remove them. So we'll start with that one last. We'll finish with that one even. Okay, these allow for unencryption. And I think it works the same with, yeah. So we can unencrypt these. So let's do God Inc. .c -o God Inc. And now okay, so everything's been encrypted, but everything still remains there, so it's not a very effective encryption method. I mean, it's not very effective at being malicious, it just creates a duplicate that is encrypted. So let's see if the Da Vinci one is any better. So we'll compile, then we'll run it and quit. Okay, so everything has been added to a zip file and then removed, so that is a success. As a final note, we have some additional features that we can talk about. So we have a malware check option, which will check if there's anything malicious going on in the files, of which there obviously is, the encryption. So it encrypts all the files with the OpenSSL command. So it's malicious. And when we're generating things, we have the option to add a keylogger or full directory encryption. This will, the keylogger will persist after the file is concluded. So you can run the file like normal, and then you won't be able to see that the process is terminated because it'll just be empty. And in testing, this has actually stung me because I forgot that that program was running, and I was typing in all my passwords and everything, and I looked at this file and had all my passwords on, so it's quite effective. This is a directory encryption, which activates at the end of the file as well, and basically it will encrypt everything on the entire computer, on the entire machine. So using it is quite deadly, and it has destroyed the virtual machines that I've tested it on. There's also an obfuscate option, which is very touch and go if it will work. So we can click obfuscate, and it's likely to just return an empty file, as it will just delete anything malicious, as the LLM finds that is the easiest way to obfuscate anything malicious going on. But luckily it renames it to obfuscated in the file name, so that this will not interfere with the actual workings. You can just have the obfuscated file if you want, and sometimes it doesn't do anything. It will just say obfuscated code and didn't do anything. So it's not a particularly useful option, but it's there. We can also scroll through all the old files that we've generated, so that if we want to make any changes using old files, we can. And that's it. Thank you.